If I'm going too fast, just say pause and I can wait for a second. Okay, so this last, or almost last page, this one here, again, just trying to go over the different types that come up. This one says the inverse is at -3 and it equals 7. So again, you can go ahead and find the inverse equation, or you can flip it. This is one of the cases where it would be faster if I didn't have to find the inverse equation before I subbed it in. So I'm just demonstrating you that hopefully if you can see it a little bit faster, it does help once in a while. So if I say the inverse at -3 is 7, and I don't feel like doing the whole inverse equation, I can just say therefore h at 7 equals -3, and then take it from my original equation. It saves you a little bit of time. Right? So find k when the original function at 7 equals -3. It's the same value, right? So I'm going to go ahead and plug that in. So I'm going to state that I did that, and I'm going to go ahead and solve it here. So that'll be -3 equals 3 times 7 minus 1 squared plus k, and we're finding k. All right, so this will be -3. That's 21 minus 1, so 20 squared plus k. Right, so -3. You can do this part faster. I know you're in grade 12, so you can do some of these calculations faster. So it'll be -3 equals 400. If you just brought it over right away and did -403, that's fine. Right, so I know you can skip some steps there. And that's it. See, when you do it using that kind of inverse idea, it should save you a little bit of time. Again, the other way is fine. It just is more work. All right. Example 5 is from grade 11 again, just trying to refresh your memory. It's directly from, I think, one of the examples and notes. I think we did it as well. So one more time. Determine the inverse of the function below. So it's a parabola, right? Quadratic. How could you restrict the domain of the function so that the inverse is also a function? So again, just trying to refresh your memory. We know it's a whole quadratic function. I want to restrict it so that when you take the inverse, I only get either the top or the bottom, right? So you have to restrict the original function so that it has half of it, so you only get half on the inverse. So let's go ahead and do the inverse, and then we'll talk about the restriction. So y equals, so hopefully this part is in your head. We're back. Switch the x and the y. Isolate for your new y. Like that. Divide both sides by the 5. Okay, you don't have to show the part in red there, but x plus 6 all over 5, or each one. Okay, at this point, either you square root both sides here, or you go to the next line and show me the plus minus. But remember, wherever you put that square root, it has to have the plus minus. Okay, so you're going to go plus minus from the very top to the bottom, right? So x plus 6 over 5 equals y plus 8. And again, if you want to do this a bit faster, you could have brought the 8 over all in one go. Okay, but make sure the plus minus goes from the top. You have plus minus as soon as I see the square root, and it goes from the top to the bottom. Okay, and bring the 8 over, so plus minus square root x plus 6 over 5, and then minus 8 on the outside. Don't make it look like it's in the square root. Okay, so that's the inverse. It is not a function, right, because it's got plus or minus. So it's got plus minus, so don't use function notation because it's not a function. Okay, and then the question was, so the inverse is plus and minus. That's good. How could you, if you wished for this to only be half, how could you have restricted the function, the original function, so the inverse is also a function? So I could restrict the domain. And what would you restrict the domain as? The left side or the right side of the original parabola. How do I do the left side of the original parabola? Where's the original parabola? Yep.
Making x less than or equal to
That's it. Or the other possible answer, the right side of the parabola. So that would be the left. And again, I didn't say anything, but just for your brain, that's your left side, and this was the right side. Okay, so it's saying when you get to your answer, it is not a function because you have the top and the bottom. How could you have restricted the original had you wanted it to be a function when you did the inverse, which means that you would have to do the left or the right side of the original function. Yes, question?
So we would have to write both, right?
I would describe, yeah. So in a communication question, I would be describing both, yeah.
Okay.
I could do
Because
one.
I know sometimes when you write or, like.
But this case, there is two possible ways I could have restricted it, yeah. Yeah, so I would describe more. Okay, any other clarification? All right. Then example 6, we have what does the inverse of the function look like? Find the equation of the inverse. So for this inverse, we know it started as a square root function, so it will look like half of the parabola, right? So what would the inverse look like? The inverse, okay? And would that be the top or the bottom, the left or the right side of a parabola? So remember, this square root, yeah, the right side, because it's the positive, is the right side of the parabola, right? So the right side of the parabola, because it's the positive. What does it look like? Find the equation of the inverse, so we'll do that, and then restrict it. Okay, so we're going to restrict it as well. So let's do the equation. Y equals 2, negative x minus 5 plus 6. Switch your x and your y. Like that. Switch x and y and isolate. So bring the 6 over. X minus 6 equals 2. Negative y minus 5. Divide both sides by 2. Okay, and to get rid of a square root, square both sides. Oh, sorry. Stop. My gosh. Okay, I put the timer earlier. Stop early. It's still recording. See if I can finish this question. Here we got that, so that cancels out. And then we're going to get, we're almost there, x minus 6 over 2 squared equals negative y minus 5. Now, got to keep answering this. I want to isolate the y. You have two different ways of doing this. I can bring the 5 over and then divide everything by negative, but also I'm going to bring the y over and bring this over. Does that make sense? And it just makes the y positive. Either way is fine, right? You can get the same answer. We'll start a new column, and we're going to go with y on this side and bring this over, so it's negative x minus 6 squared, and leave that there. So that gives me, right, the whole parabola. When I graph it, the graph would be the whole parabola. Now I only want the right side of the parabola. Where's the vertex? Purposely gave you one where you're like, ah, look at that vertex. Yeah, where is it?
3, negative 5.
Not 3. It's not. That's why I gave it, because you want to divide the 2 in. Watch. I'm going to rewrite it. You don't have to, but it's 1/2. It is factored out. When it's all divided, it's actually factored out. So don't divide the 6 by the 2. That's why I gave you this one on purpose. It's harder than the ones we gave you last year. We never gave you stuff on the bottom. We gave it single, right? But we didn't give you the one on the bottom. But then there's a fraction on the bottom. It's actually in front, factored out. So my vertex is still at 6. That's why I gave you this one. Okay, because we never gave you kind of tricky ones with that. It's not really tricky. It's beautiful. It's a beautiful one like this one, but it's a 6. Right, so the vertex, so that's why I was like, oh, that's going to get you. So the vertex of that is 6, negative 5. Okay, so don't divide it by the 2. It's very tempting, but technically it's pushed in front. Okay, so then my restriction would be x, and we want the right side of the parabola greater than or equal to 6. Okay, so that was a little tricky here. Okay, you don't have to rewrite it, but it's this. that 1/2, because it's under the whole thing, so it's actually factored out in front, so you don't bring it back to the 6. Right? That's different. Any questions with that?